Hi, and welcome to the Kubernetes podcast from Google. I'm Craig Box with my very special guest host, Jimmy Moore. Everyone had to change where they were, how they did their work when the pandemic first hit. There's a picture of a radio host Ira Glass of This American Life fame, barefoot in a cupboard, wearing a suit, no tie I should point out, but he is in, again, what I would call a cupboard or a wardrobe, what they call it, a closet in the US, holding a laptop in one hand, recording his voiceover. And I mentioned that this week because, Jimmy, I find you in a very similar situation.
Yeah, I am literally in the closet in my house because there's some work being done on my house. But yeah, I'm in the closet and it's frankly been many years.
What is the work that is being done?
Oh yeah, we're getting some windows replaced in the house, which turns out in San Francisco is a pretty large undertaking when it comes to permitting and keeping the windows in the front of the house looking, how they expect to. And it's quite expensive. I'm glad I don't own the house in this moment.
I've heard that the material matters.
Yeah, the permit actually says the street-facing windows have to still remain wood, and the ones in the rear can be composite or whatnot. But frankly, to me, they all just look like painted white plastic, so I'm not really sure what the big deal is.
We're in a very similar situation here. I've been petitioning for many years that we should have double-glazed windows installed, and finally, they've come around just in time for us to be moving out.
It's always a nice upgrade, right?
Just a little bit of housekeeping now. We're going to take a break for a couple of weeks. We'll be back in the week of KubeCon with our regularly scheduled KubeCon extravaganza. Unfortunately, of course, we're not going to be in person at KubeCon. It's very hard for people from Europe to attend things in the US at the moment. The rule for that is actually changing, but not in time for this event. So I would encourage anyone who has a Kubernetes podcast-shaped hole in their life. We have a back catalog now of over 160 episodes where you can catch up with the full gamut of topics, everything to do with Kubernetes and Cloud Native. Go back and find an episode that you haven't listened to. There's some really good ones back at the beginning. Pick a topic that you perhaps don't know anything about. You will learn something. But don't forget us. We will be back.
And, I'll be going back and listening to the ones where you interview the people who are planning the KubeCon events throughout the years, because to me, that is fascinating. So I'll be picking up those.
All right, let's get to the news.
Google Cloud has launched a new service for continuous delivery to GKE. Google Cloud Deploy is a managed, opinionated CD service. It was built as a result of deep dives with over 50 GKE customers on what the perfect CD system should look like. It uses Scaffold for rendering manifests, integrates with first and third-party continuous integration tools, and has a full UI for viewing pipelines and providing approvals. It's available today in preview.
The results are in for this year's Accelerate State of DevOps report, published by Google Cloud's DevOps Research and Assessment team. The report continues to show that excellence in software delivery and operational performance drives organizational performance, the sort of thing that might make you consider a new GKE deployment service, for example. This year's report also investigated the effects of SRE best practices, secure software supply chain, quality documentation, and multi-cloud against the backdrop of 2020's effects on culture and burnout. A copy can be yours for the low cost of your email address.
Mirantis, operators of OpenStack and Kubernetes infrastructure, now want to abstract away your data center. Mirantis Flow, launched this week, is a data center as a service product, combining their container cloud with 24/7 monitoring and operations support. It hopes to replace the existing infrastructure software you run, and thus pay for, with something more cloud native. Learn more about Mirantis in episode 110.
Once upon a time, a scrappy team at a hosting company created a platform as a service based on Kubernetes. That platform was called Deis, and that team was later acquired by Microsoft. Now, in a case of life imitating art, the Deis Labs group has released another platform as a service, this one supporting their experimentation with WebAssembly. Hippo takes a fresh spin on the PaaS ecosystem, with advantages like true build once, run anywhere, and the speed and security built into WebAssembly. If good things continue to come from this team, perhaps they'll be acquired again.
Docker is doubling down on their recent pricing and subscription changes, claiming overwhelming positive support from their community in a blog post. They have announced some changes to their roadmap brought on by the new investment, including the acceleration of work on Docker Desktop for Linux. That's one way to go. Stay tuned to hear about another.
Supply chain security continues to be top of mind, and the Google open source team continues to drive progress against the new SALSA framework. The base images provided by the DistroList project receive over 16 million pulls per month and are depended on by large projects like Kubernetes and Istio. DistroList builds have now achieved SALSA Level 2. This means that in addition to a signature, each DistroList image now has an associated signed provenance. Learn all about provenance and salsa with Priya Wadhwa in episode 155.
Finally, the 6th CNCF end-user radar has been released this quarter, focusing on DevSecOps. 21 companies that rely on cloud native offered their recommendations on security tools. 16 made it to the final round, and the group suggests the time is right to adopt 8 of them, including OPA, HashiCorp Vault, and Istio.
And that's the news. Daniel Walsh is a senior distinguished engineer at Red Hat. He has worked in the computer security field for over 30 years and has been the leader of the Red Hat container engineering team since 2013. Brent Baude is a senior principal software engineer at Red Hat. He is the architect and primary maintainer of Podman and contributor to many of its associated technologies. Welcome to the show, Dan.
Thanks for having me.
And welcome, Brent.
Likewise.
Dan, your 20th anniversary at Red Hat just passed. It's hard to imagine, but the company was 8 years old when you joined. Does that make you an old-timer or a newbie?
I'd say I'm an old-timer. When I joined Red Hat, there was about 400 employees, and now I think there's around 18,000 employees, not counting our parent company, IBM.
It does seem like the kind of company that develops lifers. Are many of the people who were there at the beginning still around?
I think there's still probably well over 100 people that are here from when I started. So, yeah, I'm slowly moving up the list of longest employees, but not that close to the top yet.
And Brent, you joined IBM in 1997 and then left there for Red Hat after 17 years. Given the recent acquisition, does that mean that you've been there longer?
I do, in fact, tease Dan about that. But I think given how IBM has treated Red Hat as its own entity, he pulls seniority.
One of the great things about the acquisition is they really treat us like a separate company.
One of the things, Dan, that you've been working on for a lot of that time is the security subsystem and especially SE Linux. There is a website which implores people to stop disabling SE Linux because it makes you sad. Are people still disabling SE Linux, and are they making you sad by doing so?
Yes, sadly, they are still disabling SE Linux in a lot of places. I mean, the thing about SE Linux has always been that SE Linux reveals the complexity of the operating system. So getting SE Linux right and getting your applications right is sometimes difficult. The beauty of containers, though, is that the container world is sort of simplified at the operating system, in that instead of having, a web server talking directly to a database server, you have a web service container talking to a database container. And therefore, we basically put these applications into a box, and then we can control the communication paths between the two different applications. And so containers in SE Linux are sort of a perfect match, simplifying the operating system down to individual sandboxed applications. And then SE Linux is a great tool for protecting. It really protects the file system from the containers. So far, most vulnerabilities in the container worlds have been basically file system attacks, right? The container breaking out of its namespaces or breaking out to actually see the operating system underneath it. And then SE Linux has been, in my opinion, the best tool for controlling what goes on in the operating system, basically those accesses. So whether or not the container process can read your credit card data in your home directory, and those are all blocked by SE Linux.
Is it still something that the people who are writing and running the applications need to think about, or is it now just an implementation detail? In your Kubernetes manifest, you say enable security, and SE Linux is the system that makes that happen.
The only place where SE Linux tends to come up in container world is when you start to leak host information into the container, so really volumes. So if you mount a volume into a container, you need to make sure that basically the SE Linux policy says the container process type can only read and write container file types. So if you take a directory out of your home directory and stick it in via volume, then you have to make sure that the labeling is correct. And what we did way back when I was working on Docker is we came up with the :Z or :Z for the foreigners.
Thank you for translating for me.
Capital Z and lowercase z. Basically tell the container engine, Docker or Podman, to relabel, basically set that content of the volume that you're sticking in to match the container label. That's really the only time SE Linux tends to come into an issue in the container world.
Now, I've been made aware that confusing Docker and containers and saying one when you mean the other is a swear jar-worthy offense on your team.
You've been doing your research.
I do want to check in on that. A lot of people will consider Docker and containers to be analogous because they've come to them in the past 5 years, where that has largely been true in terms of public opinion. When you started in 2013, that was before Docker. What did it mean to lead container engineering at that time?
Going back in my career, I've been working on what I would call container technology, although we didn't use the word container, we used sandboxes. All the way back to basically around 2006. I was working on SE Linux at the time, but what we were trying to do is to sort of create these controlled sandboxed environments. And we were introducing into the kernel things like different namespaces. The original one was the Mount namespace. And later, when RHEL 6 came out, I created a thing called the SE Linux sandbox. The goal there was to create multiple home directories so that you could run, say, two different versions of Firefox or a web browser where one would see the internet and the one would see your internet. And then you could isolate those two from each other. And what I was doing there is using Mount namespace to create different home directories inside of and then using SE Linux to control what was going, basically access outside. I wasn't smart enough to call this thing a container, but that's actually existed way back then.
That's branding. You need a marketing team for that.
Exactly. I also worked on the original version of OpenShift, which was a web-based service where we would give out accounts basically for free. You give us an email address and we would give you an account on Red Hat services, and you were allowed to develop applications. Well, obviously that's opening up a world where we had lots of hostile users getting accounts, and we had to control those accounts. And again, we used SE Linux to control those accounts. Around 2013, we were looking at increasing OpenShift's controls, basically adding in a lot of the namespace stuff that was in the Linux kernel. We created a thing called OpenShift Gears, and these things were like containers, basically. So we were working heavily on that. I was working on another thing called the Virt sandbox, virtualization sandbox. That's when Docker sort of became the hot thing on the internet. So we pivoted inside of OpenShift and started looking at Docker as basically this new hot technology that everybody in the open source world wanted to use. And very quickly, we wanted to get that into RHEL and into OpenShift. And that's when I started leading the team that was basically making Docker what we call enterprise ready. So we added all sorts of features to Docker. Docker at that time was using a file system that was not part of the upstream kernel. So people on my team added device mapper support and later overlay support. We also added SE Linux support to Docker and things like that. And so for the first couple of years, we worked heavily on what I would say is making Docker enterprise quality so that we could ship it and support it inside of RHEL.
Brent, your last couple of years at IBM were actually working with Red Hat. You joined the containers team around the same time in June 2014. What were some of the first things that you worked on?
We worked on the Atomic project, which Dan was there as well, and primarily Dan and I at that time were working on a tool called Atomic that was Python-based for, believe it or not, managing containers and adding some specific features to Atomic that wasn't present in most container runtimes.
I remember Atomic as being the name of a distribution, which was sort of a cut-down version of RHEL designed to be the base for containers. Was that a thing that came later?
I think it was hand in hand, if I remember correctly.
Yeah, Atomic was basically a tool that ran on top of basically the Project Atomic operating system. Eventually, when Red Hat purchased CoreOS, Project Atomic and CoreOS sort of merged. The goal was to take the best technologies out of CoreOS and the best technologies out of Atomic and merge them together. What we were experimenting with the Atomic command line was to sort of advance features that at the time Docker didn't have and things that we thought were necessary, things like scanning and tools like that to look at images and sort of to enhance on top of it.
I think that may well end up being the theme of a lot of the things you've worked on here. You said that you were working with the Docker team and building enterprise features in, but then there are a lot of things that you've built which are sort of substitutions or complementary to Docker itself. When would you decide to build something yourself versus enhancing the upstream product?
We continued work on the upstream project, but we quickly found that some of our ideas started to conflict with what Docker wanted to do. I mean, for instance, we wanted to support multiple registries. Docker wanted to hardcode Docker IO as the only way to use registries. Slowly over time, we had our own version of Docker with lots and lots of patches. Now we were trying to get those patches upstream, but Docker was hostile to them. We also wanted to get better systemd support. A lot of our users wanted to be able to run systemd inside of a container. upstream Docker was fully hostile to a lot of these patches. So slowly over time, there was seen to be this conflict going on at all times. Docker was this huge success, but I also had a problem with their whole design. The way I look at Docker is they had a tool similar to OpenShift. It was really a REST API tool, and then they built the Docker daemon based on that. So you took a lot of engineers who were really looking at developing web applications, and they built an application that was really a client-server application. So a lot of people don't understand is when you run Docker, it is a client that talks over REST API to a Docker daemon, a root-running daemon. Mm-hmm. It asks it to launch containers. So the container is not a child of the Docker CLI. It's actually a child of the daemon. And I always looked at container processes as they're just regular processes in a system. So why couldn't I just have a tool that just launched a container as a child? Most of the engineers from Red Hat come from an operating system point of view, fork exec model where process is a child of process. Mm-hmm. So we started to look at it and said, why do I need these daemons? And if you looked at how Docker was evolving at the time, Docker was originally just a daemon. Then Docker was a daemon with, they had these plugin volumes, and those were daemons. And then they had these security authorization daemons, and there's this proliferation of these root-running daemons just spreading all over. Eventually, Docker even split into Docker and Containerd as two different daemons. So there's always this proliferation of daemons, and I always kept on coming back to, these are just processes. Why do we have to do all this stuff? So we started basically a skunkworks project to figure out, could we basically take some of the technology that we had given to the Docker project and pull some of it out and just look at, could we just do these containers without having to always talk to a daemon? And so we started working on things like Podman. Then we wanted to do something that was dedicated to Kubernetes, and that was what Cryo. And then we wanted to do some kind of tool to build container images that didn't need to talk to a daemon. That was Builder. We took apart what Docker did into its core components and built a library to do the storage of images, and that's container storage. And then we built a library called Containers Image, which does the pulling and pushing of images back and forth to container registries. Made those separate libraries. And then we started building tools on top of those. And out of those came three tools I just mentioned, Builder, Cryo, and Podman, and also a fourth tool we called Scopio, which is just really a tool for copying images between different types of container storage. All of these share the same underlying libraries and share the same underlying content. Podman can use a Builder container, and Cryo can use Podman containers and Builder images. Started to build up the tools separately, and in my opinion, more like a Unix model where each application does one thing and does it very well. Obviously, that's where Podman became sort of a glue code, and we had to have something that worked like Docker. The one thing I didn't want to have when we were first talking about designing it is Google knows how to run containers, and that involves this Docker command line tool. So how do I take a directory and stick it into a container? I do it run-v. We decided very early on that all of the Podman commands had to match exactly the Docker commands. So the only thing you had to do is change DOCKER to PODMAN, and everything would work correctly.
All the examples even still line up in a monospaced font.
Yeah, exactly. That's a reason, because Google memory is very long, and we were never going to be able to do that. And I consider Podman to be the Pepsi to Docker's Coke. That's the way we want to go.
Around that time as well, Docker were reticent to standardize their container image spec or their runtime spec, and it really took the AppC project coming out of CoreOS to sort of get everyone else to align around a Pepsi, if you will, such that Coke decided that they needed to publish their secret ingredient. I'm not sure quite how far we can strain this metaphor. Was this all around the same time?
CoreOS was still a separate company at that time. They weren't part of Red Hat. CoreOS had developed the Rocket package, and they were trying to push that as an alternative way of running containers. At that time, everybody called them Docker images, but it had a way of describing a container image. And really, a container image is nothing more than create a rootfs, basically something that looks like root on a Linux operating system. You put some content into it, and you tar it up. Then you create a JSON file associated with that tarball, and the JSON file has sort of the fields that you see in a Docker file, the environmental variables, the maintainer, the commands to be run inside of the container, and you combine all that together, and that's really what a container image is. The problem is that JSON file wasn't standardized. Mm-hmm. So anytime Docker wanted, they could go on and change the standard of the JSON file. Coming from my long history in Linux and Unix, having Microsoft controlling the .doc format has not been a great thing for the world. Well, it's been a great thing for Microsoft, but it was back in the 90s, it wasn't a great thing. So there was a push to standardize, basically get a standard so that people couldn't make arbitrary changes to force everybody to upgrade their tooling and pay more money for upgrades, similar to what Microsoft had done over the years. So when CoreOS came out with this standard, Red Hat sort of agreed this shouldn't be controlled by one company. It should be a standards body for controlling what the format of these images are. The other fear was, if you go way back in the Linux world, 25 years ago, RPM and Debian format came out, and suddenly, forever, we had two ways of shipping software. In the Linux world, anybody who wanted to ship an application had to package it at RPM and package it at Debian. With container world, there was container images, and what we didn't want to have is two ways of everybody ended up having to ship images in two different formats. So that's where really OCI came about, and OCI obviously allowed us to really begin to standardize. Right now, all of our tools run basically the exact same OCI images that Docker runs, and we create the exact same images. So the input and the output, the way we run containers is exactly the same as Docker, and the way the images that we use to run containers are exact, and those are standardized inside of the Open Container Initiative, OCI.
A lot of people will come to this episode with the thought in the back of their head that Podman is a drop-in Docker replacement and that it doesn't require the daemon. That's probably selling it short. There'll be a lot more that it can do. What are some of those extra features above and beyond the Docker functionality?
The first thing is the pods. Of course, that's where the name comes from. Mm-hmm. We are able to support pods in Podman. They differ slightly in actual implementation from a pod that you might know in Kubernetes, but the behavior is essentially the same. We also have this notion where we think the long-term feature of Podman is we have this notion of being able to run some containers or pods locally and then capture them in Kubernetes format, like a YAML file format. Mm-hmm. That's called a generate, and then we have a play command that allows you to replay that with Podman. However, you can also take that same YAML file and throw it at Kubernetes, and you've got the same thing running there. That interaction is what I meant by this is where we think our future and growth can be, and continue to make that easier for people, continue to make that a seamless transition, perhaps even a basic component of what developing a services container, for example, might look like. Try it out locally, lift it to Kubernetes, it works fine. Or if you need to debug something that's failing in Kubernetes, you could theoretically bring that down on your single node with Podman, run it, and get a good idea what's going on.
That's one key feature that Podman basically can run pods and really sort of bridges the world between sort of running local containers and then running containers in sort of a distributed Kubernetes environment. So we wanted to make it easy to go from the simple Podman command line to this more complex Kubernetes YAML file just by saying, oh, I created these containers, they're running great. Now I do a Podman generate kube, and out pops the Kubernetes YAML file that's ready to take the containers I just built and run them in a Kubernetes world. Me coming from a security point of view, I think the big advantages of Podman over Docker show themselves in probably Podman's most popular thing, which is that it runs as rootless mode. Because we're doing the simplified creating of a child process underneath it, Podman was able to easily plug into the user namespace world, and suddenly we were able to do almost everything you can do as a rootful Docker or a Podman you can do in rootless mode. And that's really what has sort of shot off the popularity of Podman. Now, Docker eventually responded, and you can sort of run Docker as a rootless mode, but some of the Docker design becomes a little bit silly when you run in a rootless mode. If you log into your system and suddenly you have to run two different daemons inside of your home directory in order to run Docker. And what I've always felt about Docker is this doesn't make sense if I just want to run a simple container in my home directory, that I have to run all this infrastructure in order to run the container, whereas I can just run the Podman command. Another problem with Docker versus Podman for running rootless mode is, again, if I just want to run a container, I want to run a container. I don't want to have to run the container tools all the time. So in Podman, I can just say Podman run, and Podman pulls down the container image, starts it up, and then disappears, right? So there's no overhead, there's nothing going on unless I want to interact with the container. But if I just want the containerized application. A couple other things. I mentioned that Docker was openly hostile to systemd. Well, Podman has sort of embraced systemd. So it's simple to run a systemd inside of your container, but we also, similar to what Brent talked about for Podman generate kube, we also have Podman generate systemd. So we can easily create systemd unit files based off of your container images. So if you build an application and you just want to run it on a service, the way you start most services is systemd unit files. So Podman systemd generate will take your Kubernetes and pods and generate systemd unit files. Then you can just distribute the systemd unit files, and people who just start up a service and it's running a containerized service. Further, we've developed on that is the idea of making those services auto update. So imagine you're doing, say, an IoT device or an edge server, these little tiny applications sitting out there on top of container images. You really want that machine to just boot up, start up your service, maybe running a Podman command inside of a unit file. It goes out to a service, pulls down an application, and starts running it. That image eventually gets updated because of a security fix or something like that. You don't want to have to go out to that machine or thousands of machines and tell them to update. So inside of Podman tooling right now, we have the ability to have it auto update, which means that basically there's a job that runs, say, in a systemd timer and periodically goes back out to a service and says, is there a new image there? And if the new image is available, it basically tells Podman to pull down the new image and recreates the container off of the new image. So now you can get basically human-free machines sitting out there running as edge servers, all because the integration between Podman and systemd is available. Those are the types of features that we're looking to add. One of the key things when we were doing Podman originally was we were doing Podman command line interface. Originally, we used to say, replace Docker with Podman. We would say just alias Docker equals Podman and you're done. Well, that was true if you use a command line, but the secondary need that we faced very quickly was the need to interact with all these services, all these remote APIs that we're communicating with the Docker socket. So Brent has led the effort to basically provide the Podman sock. So I'll let Brent talk a little bit about what we've done in that area.
It became very evident to us that our users really, really needed something that simulated a Docker socket. And that was not our traditional approach with Podman, primarily being CLI, as Dan mentioned at this time. What we ended up doing is creating a similar RESTful service for Podman that serves up really two layers of service, if you will. One is a pure Podman set of APIs that were implemented. It also offers a layer of services that mimic Docker's API. What people were really after is, suppose they had written an application that used Docker Py, the Python library, for communicating with Docker. They wanted to be able to redirect that towards a socket that was controlled by Podman and be able to run their application without having to port. That quickly became, I want to run Docker Compose, I want to run these Java test utilities, I want to run the Docker CLI on top of Podman. It went sort of nuts. That's always something that Dan and I find interesting is we may release some sort of feature or whatever, and our users just run with it, and they run it to exhaustion in terms of this is what I wanted to do with it. And we sit there and marvel at we've never even thought about these kinds of things. We were just trying to plug a hole or offer a new feature.
Well, it sounds a little bit like what Dan was saying before about the distinction between the web-based approach or the monolithic API service approach from Docker the company versus Red Hat people being operating system people. It almost feels like you're having to implement things that you don't necessarily agree with or you wouldn't necessarily advise people to use.
It does complicate matters because you now have a socket, even though we use socket-activated services with systemd. So it's not technically running all the time, but you do have these extra doors that can be abused if the circumstances are dead right. So that really wasn't our model. It really wasn't our approach, but it became very clear that in order to be successful, that was something being heavily, heavily used by users, customers, companies, however you want to say. Mm-hmm. And we would have to be able to do the same thing. And in fact, it translates about everywhere. The same thing would be true for interacting with, say, GitLab, who's got services that run on localized runtimes, and they use the APIs to communicate back and forth. In order for Podman to be able to be used in the same manner, we were going to have to offer similar API such that we don't require everyone to have to redo a whole bunch of work.
In a perfect world, we'd prefer everybody to write their multi-service applications in Kubernetes YAML. But Docker Compose has this huge installed base of applications that have been built based on Docker Compose. Basically, we're forced to allow these people to actually work. As a matter of fact, there was projects in the open source world like Podman Compose, which was attempting to do what Docker Compose does, but with the Podman command line, but was falling somewhat short of what people expected. We really had to have basically a socket that could implement what the Docker sock did. Interesting thing that we did do, though, in addition to that, and it's always like embrace and then extend it to add additional features, we actually added the way to run Docker Compose rootless. So we actually provide the Docker socket in rootless mode so that you can run your entire Compose scripts with never having to be root on the system. So again, using sort of the really core underlying technologies, we're able to enhance and add more security to what you were traditionally able to do with just a Docker daemon.
I would like to just clarify when Dan says that we believe that PlayCube and YAML files are better over Docker Compose, for example, what we're getting at is that file is multi-purpose. You can run it in Podman, you can run it in Kubernetes. You create a Docker Compose file, and it only works with Docker. Had we not implemented those common APIs with Docker, it wouldn't work with Podman either. That's why he's sort of indicating that this seems like a better solution because it has more uses and more commonality with the rest of the world.
Yep.
You mentioned before people wanting to run Docker in Podman. There was obviously a world of opportunity opened up when people were able to run Kubernetes inside Docker. Does it make sense to run Podman in Podman?
I just wrote 2 major blogs on that because that's a very common question we get. It does. Most people do it for CI/CD systems. Mm-hmm. So a lot of people wanted to test their containers or build their containers inside of the CI/CD system. And usually they want to run Podman inside of Docker, or they want to run Podman inside of Kubernetes, or they want to run Podman inside of Podman. They also, Builder, which is the underlying technology that we use for Podman build, is similarly used. The reason I wanted to write the blog is Podman opens up this incredible amount of variety of ways that you might want to run Podman inside of a container. The blogs are available at redhat.com/sysadmin, or just Google Podman inside of a container.
Or read the show notes.
Oh, the show notes, yes. It's a very common request to be able to run containers within containers, and therefore Podman inside of containers. And people are doing like Kubernetes inside of Podman now. Everything gets turned on itself. And I'm sure somebody somewhere is probably running a Docker daemon inside of a Podman container as well. So every possible combination.
And in case anyone out there is only listening and isn't reading along with the show notes, we should point out that Builder is actually spelled Buildah, and it's not just the way Dan says it. Although I'm sure that was why it was named that way.
It was to make fun of me speaking correctly with the Boston accent.
Kubernetes used to use Docker as its container engine. It has now moved to Containerd and slightly more appropriate leveled runtimes. Does it make sense to use Podman as the runtime for Kubernetes, or is that the job for the lower level runtime under it, like CRI-O?
The 2 major tools for running containers in Kubernetes now is Containerd and CRI-O. When we developed CRI-O, which actually predates the creation of Containerd, CRI-O was really using the same underlying technology as Podman, that container storage and containers image. Our goal with CRI-O was to really dedicate and lock down the container engine that Kubernetes would use. During the years when OpenShift was first being developed on top of Kubernetes, every time Docker would update, Kubernetes would be blown away by all the changes. Mm-hmm. It was incredibly unstable. Not anything Docker was doing incorrectly. It was just Docker was updating its APIs and things like that. And Kubernetes was having a hard time keeping up. We had problems with people using a version of Kubernetes that didn't match up to the version that we tested with Docker. When we developed CRI-O, we wanted to basically dedicate If you're running Kubernetes 1.10, you run CRI-O 1.10, Kubernetes 1.11, CRI-O 1.11, and then we would test them together in a single unit. CRI-O really is taking our underlying technologies and just looking at the specific version of Kubernetes and then optimizing everything in the world to run with it. Docker created a competitor to it called Containerd, which does pretty much similar things to what CRI-O does. In my opinion, Containerd is a more closed-in, monolithic environment where CRI-O is, again, built on top of underlying libraries that are fully open-sourced, as opposed to being one entity.
I don't know what the relative amount of usage of both of those platforms is, but I think a lot of people might think of CRI-O as being the runtime under OpenShift, and most of the other implementations tend to use Containerd, as I understand it at least. Is there a point where you're sort of swimming against the tide and maintaining your own thing, and you would be looking to merge those things? Or do you think that having multiple implementations of the same idea, like you've said before, is useful in helping make sure you don't have a monoculture around one implementation?
I always find it funny that in a world where we have 10 different web browsers and 40 different ways of editing files and lots of different ways to doing almost everything in the world, everybody wants to have a single way of running a low-level container engine that is working underneath Kubernetes. I don't see us as swimming against the tide because this is more of a group of 3 or 4 engineers working on something that we can make work perfectly with the way OpenShift and Kubernetes wants to work. First of all, CRI-O is used in other worlds besides OpenShift, but even if it's just dedicated to OpenShift, if we can get the best OpenShift experience out of CRI-O, why would we necessarily want to work on Containerd? Lastly, the underlying engines aren't changing all that drastically. These things aren't rapidly evolving. They're changing slowly over time, and that's goodness, right? That means that there's a stabilization going on. So there's not really a huge amount of differences between Containerd and CRI-O, but they do work very independently. One of the things that CRI-O can do that Containerd can't do is take advantages of enhancements that we put in for things like Podman. So some of the ways that we do use the namespace inside of Podman get evolved into CRI-O, and some of the advanced features, some of the image signing, things like that. To us, moving to Containerd doesn't make much sense at all.
Within the last few weeks, let's just say there has all of a sudden been a desire to look at good desktop experience for running container environments. Coincidentally, with any announcements that may or may not have happened, there has been support announced for Podman on Windows and Mac. Were those things completely coincidental?
Yes.
That's good luck on your part, then, I should say.
And a little bit of no.
I take it back.
I like to tell an old IBM adage about development in a non-open source world that IBM used to be. There was an old adage that IBM doesn't release products, they escape. Mm-hmm. We had a little bit of that this time. The support was actually there and had been upstream. I believe it had been released one version earlier in 3.2, but it was a limited working version.
We're talking about Podman on a Mac.
Yeah, and it didn't have the network proxying and a few other things. We were working on it anyways for 3.3, and 3.3 happened to go out. That said, it was a little bit of forcing our hand. We weren't quite ready to totally go for it, even though that feature had already been in Podman and people were using it even prior to 3.3, using it primarily to build images, which is something it did well at that point. So it was a little bit of both, but it was largely coincidental in that case. Now, on the flip side, we've seen a flood of interest and users flooding to report bugs, which there are, about it. It's been remarkable, unabashedly remarkable.
To go into a little bit of the history of Podman on Mac, first of all, a lot of people think that when you're running a container on a Mac, you're running it sort of natively. That's another misconception. Containers are really a Linux thing. So when people talk about containers, they're running them inside of a Linux operating system. There are Windows containers, but we'll push them off as being this tiny subset. When people talk about most containers, they're talking about Linux operating systems. So whether you're using Podman or Docker on a Mac, you're talking to a service that's running inside of a VM to run a container. Podman actually, Brent, most of the work on this. We wanted to create an experience where someone would just install a Podman on a Mac, then run Podman, and it would notice that you don't have a VM and would basically pull in a virtualized operating system that you could then Podman on the Mac could talk to launch your containers. Brent built what we call Podman Machine. Simply, if you just install Podman, you do Podman Machine init, it will go out and grab really Fedora Core OS and pull it in onto the machine. We'll do all the configuration to run the VM. And then if you do Podman Machine start, it will actually start up the Fedora Core OS. And then the Podman commands would be pre-wired then to talk to Podman inside of the VM. This is very similar to what Docker Machine is doing underneath the covers. As Brent said, when the announcements happened over the last couple of weeks, we had just basically completed the technology to make it work. And we've been fairly happy that we weren't even ready to really announce it and start pushing it when all of a sudden we get this flood of interest in it. Now we're having meetings to talk about how could we add the graphics tools, the graphic capabilities, because a lot of people want to do things like have a little Podman icon in their desktop and click on it and say, I want to stop the machine or start the machine or refresh the machine. And a lot of that, what I call Chrome, doesn't exist yet. So that's the thing we're working with the open source community to add to the Mac. The hard part for us really is not the Podman parts of this. The hard part is figuring out how do we deal with operating systems, right? How do we deal with these virtual machines? And even when we're looking at Windows, we have the same type of issues. So when we look at WSL2, people say they want to run Podman, but Podman's available on 10 different distributions. We want to end up with people having the best Podman experience. So we really want the upstream Podman project to sort of recommend which distribution you're going to run inside the WSL2 to get the latest version of Podman and things like that. So we're working out the logistics of how do we do that. Right now, and for Mac, we're doing it with Fedora Core OS underneath the covers, just because we work well with the Fedora community and can sort of guarantee that they have the latest version of Podman on the service, so it matches up to the Podman client that's running on the Mac.
Apple Silicon support is coming. We didn't take the same approach that Apple did in the sense that they ship their own QEMU. So we've been waiting for these enablement patches for Apple Silicon to get into QEMU proper, as it would be typical of Linux and open source and Red Hat to do. We've actually been granted a workaround from Brew to go ahead and put them in now. So that should be very, very soon. And in fact, maybe even in 3.4, which is being created as we speak.
With the way that you've described the different models between Docker and its socket and Podman running processes locally, as the user who's executing the command, it would make sense that the Docker approach worked well when you just have the client on the Mac and the service, if you will, running on the VM. What changes did you have to make to Podman to be able to support that disconnection?
Very little, in fact. It wasn't well known, except to the team, that Podman has what we refer to as a remote client. And there's actually a binary called the remote. The main Podman binary, the regular one that most people use, also has the ability to be a remote client and just connect to a Linux VM anywhere over SSH securely through our system connection management in Podman. That whole conversation of I'm sitting on a Mac, in fact, that's the way you ran it on a Mac before, is you ran the Podman remote binary, and that connected you to a Linux VM somewhere. But the difference was then you had to create that Linux VM or you had to create that Linux server yourself.
Whereas now it's just Podman init, for example, and it will make that happen for you.
Correct. Dan talked about having a better user experience. Some of it, much like the API conversation, was something we had been talking about. Do we really want to go there and now start dealing with VMs and the fact that there isn't a consistent VM technology across all these platforms we try to support? Again, it became evident by user feedback. Yes, you do want to go do that. And so we had to take the dive.
One of the things that we did when we were developing the socket is we wanted to make sure that all of the Podman commands would work against the socket as well as locally. So our entire development tool chain and the CI/CD system is always checking Podman and what we call Podman remote against the socket to make sure that the interfaces work exactly the same. We always had Podman remote. As Brent said, there is a Podman -remote to allow you to take this sort of standard Linux Podman and talk to remote machines. Now, I would like to point out that On a Mac, it is Podman Remote talking to a Podman inside of a container. In Windows and WSL2, Microsoft has done some really cool stuff. It is running the real Podman inside of, say, the Windows shell, the PowerShell. So it's not really using Podman Remote when you're running with the WSL version of Podman. I'm not sure how they do it, but it actually works. We've been told by lots and lots of our users just love the way that Podman works on a WSL too.
You have a full set of tools here which now replace and provide all of the things that were provided by Docker. Where is Docker left? For example, you still create a file called Dockerfile. Is that the only place that string needs to still exist in everyone's workflow?
We have a file called container file that does the exact same thing.
You've thought of everything.
I'm always telling people, how can we get rid of the Docker adjective? We have Docker ignore, which is a way of building images. There's a special file called the Docker ignore. So we also support not only the Docker ignore, we explore container ignore, and we have Docker file and container file. They're both the same thing. So I'm always looking for how do we get the Docker adjective out of things. We realize that we always have to support sort of the traditional way that everybody thinks of containers. We have to sort of match and use those tools. As Brent says, we're always surprised when we add a new feature. One of the things we were surprised with in the last couple of weeks is our tools. We barely got them out the door, and everybody's using them, and everybody's happy with them. They work pretty well. And then all of a sudden we start getting bug reports that says people on a Mac running Docker Compose, and we didn't leak the Docker socket out of the VM onto the host, and they're disappointed that that doesn't work. We would never even thought about that. So suddenly we have all these new issues coming in about people wanting to do remote APIs from the Mac to sockets that are leaked out of VMs. So now we have to figure out how do we handle those types of issues. Is it always an expanding world that we're having to deal with?
I think we see Docker references, Dan, still in some of the documentation for the common API, as well as the Docker schema for image formats and whatnot. That's still a capital D Docker standard, if you will, referred to as a Docker schema.
You'll always have to have the alias Docker equals Podman line in the docs, but that's got a lowercase d, so that's probably okay.
Docker Inc. did a fabulous job of embedding their name into everything, but I think that also was a double-edged sword for them. It's something that they've had a hard time dealing with, in that they wanted to differentiate the Docker Enterprise thing from this Docker open source tool. Way back when I started at Red Hat, we had Red Hat Linux. At the time, Red Hat Linux was the thing we wanted to sell and the thing that we're giving away for free. Eventually, we split. We created Red Hat Enterprise Linux, and then we created Fedora as two sort of separate entities, and that allowed us to really differentiate. So while Docker was able to get their name everywhere, they sort of almost like Kleenex, or I guess Xerox, everybody might refer to every box of tissues as a Kleenex. All of a sudden, everybody can sell tissues, and people don't really care whether or not it has the Kleenex name on the box or it doesn't have the Xerox name on your copier machine. Those things are double-edged swords at times. Personally, I don't like people calling them Podman containers. I'd prefer to everybody just call them containers. We don't need to start the Podman registry and the Podman image and the Podman container. These are containers and these are images, and it's just...
And then we'd have to start arguing about how you pronounce key.
Exactly.
Brent, would you say that the roadmap for Podman has changed substantially in the last 3 weeks?
Some of the priorities have been swapped around, but all of the ideas were still in the queue. Definitely, it's been impressed upon this team, both internally and externally, to continue to make the Mac solution the best we can, including a vision that would have a desktop experience. There's some level of tightening up some things around the WSL in terms of making certain little tweaks that make it fully functional, particularly in the areas of System D.
You've mentioned, obviously, there are a lot of engineers at Red Hat and a lot who are working on this, but I don't know how many Swift developers you may have on staff, for example. Is this an area that you're looking for community contribution?
Absolutely. And whether Swift is even the right approach, we're still having that conversation. Should it be something more JavaScript-ish or HTML5-ish that could be used in Linux as well as Mac? I think I'm the most qualified Swift programmer on the Podman team, and I have about 10 days of experience with it.
I played with that little Swift Playgrounds tool on an iPad in an Apple store for 10 minutes once, so I may be number 2, who knows.
We had a meeting on September 16th with the community. We meet every third Thursday of the month, and we call it the Podman Cabal. What we're looking for is to really nail down the requirements of how we want Podman on a Mac to work. We're looking at what the GUI requirements are going to be, which sort of help us get priority on which features we want to get on Podman on Mac. We want to sort of really look at that and pick out the best recommended way. And I love having lots of people doing lots of different ways of doing Podman, but the thing that comes out of the upstream Podman project should be the preferred way, or the recommended way of running it. So that's what we're after.
Dan makes an excellent point. It's something that I've been preaching with the team lately and people that I talk to in the community, in the sense that it's not necessarily good enough to mimic what Docker does. We really want to exceed that and add our own features and twists on top of that. That's why I'm personally not compelled to just get something out in Swift and say, okay, now you've got a fancy icon that says it's running or it's not. I'd kind of like to look at a more whole picture from the community's perspective that actually uses this. We just write code. We're not necessarily the best container minds in the world with regards to some of this. It's certainly not in GUI.
I will say it is very important that you have the icon there so I can tell that the thing that's eating up all my RAM can be stopped with a single click.
We understand that aspect, but what are the other ones that really need to be there? And whether or not does the one decision affect being able to do the other and things like that are important to consider now. We don't have anything now, so now's the time to think about it and listen to what our users want and then make a decision and get rolling.
We had a lot of people opening up this full discussion in GitHub right now about adding a GUI to Podman for the Mac, and there's a lot of people coming in and saying they don't want a GUI for Podman, or they want it to be separate,
right?
Because they just want the command line experience. They don't want any bells and whistles. They want to make sure that we allow them to install Podman without the GUI as well as Podman with the GUI. I've been a Red Hat for 20 years, which means that I've been running on a Linux desktop for the last 20 years, and my opinion on what a Mac or a Windows experience should look like should be taken with a grain of salt, let's put it that way. And so we really want to listen to people who live in that world all the time and match their expectations.
Where should people go if they want to be part of this process?
Podman.io is our website, and that's the easiest way to find out all information. A lot of our communications goes through GitHub, so GitHub issues, so github.com/containers/podman. We're old school. We live on IRC. We're up on LibreChat and Pound Podman, although that's all mirrored now inside. I'm told by these young ones that it's mirrored through Matrix and Discord, whatever those things are, for these people who want it on their cell phone, I guess. That's really where the engineers tend to lead. And there's a Podman mailing list, too, available in podman.io.
All right. Brent and Dan, thank you very much for joining us today.
Thank you.
Thanks for having us. That was great.
You can find Dan on Twitter at rhatdan, and you can find Brent at BBAUDE. You can find Podman at podman.io.
Thanks for listening. As always, if you enjoyed the show, please help us spread the word and tell a friend. If you have any feedback for us, you can find us on Twitter at KubernetesPod or reach us by email at kubernetespodcast@google.com.
You can also check out our website at kubernetespodcast.com, where you will find transcripts and show notes, as well as a great archive to binge on for the next 2 weeks. Until then, take care.
See you later.